Hey everybody, this is Larry. This is day 9 of the Leetcode March Daily uh, Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Um, yeah, well, that mic was a little far away. But yeah, I'm back in New York as you can see. I slept a little bit better, so hopefully I'm okay. I don't know. Feels like I just got back and it feels like I've been forever. I don't know. These lifetime, everything feels a little weird. I don't know anymore. Anyway, not that you came here to hear me say that, but alright, today's problem is remove duplicates from sorted list 2. Now given head, delete all notes that have, okay, so it already sorted? Okay, this should be pretty straightforward. Wait, I thought we had to remove stuff that was, I thought we have to remove all except for one, but that's okay too. That's easy to do. I think one trick that I would say, and well, feels like recently there's been a couple of linked list problem. That's one, which is fine. I guess it comes up on interviews from time to time. The second thing I would say is, yeah, one thing to do with linked lists that I've found in general is, well, the two things. Keep adding more things. Oh man, I'm yawning. But the two more things, right? One is that if you have issues with pointers, make sure that you just draw them out somewhere. Make, every step of the way of your code, especially your while loops and for loops, and see how they progress as you progress through the code. The second thing is that I found that it's easier to deal with not the current node, but the next node, so that you could delete it, because you delete a node by removing it by previous nodes, removing it next node, right? So those are the two things I would consider. So yeah, the thing that I always like to do is just have a sentinel head that basically points to the new head, or to the old head rather, and then just have a current as you go to new head. And then now, so one thing that you will see about duplicate thing is that because it is a sorted list, whoops, what did I do? It's just looking at the next node and then the node after that to see if they're alike, right? So, okay. So while current is not none, and at the end we want to return new head dot next. But before that, so okay, so what does it mean, right? That means if current dot row is equal to current, well, we want to look at the next node, so we always do if current dot next dot row is equal to current dot next dot row, we removed next dot next, right, or something like that. One of those two, it doesn't really matter. And this will be a while loop. So the idea behind this algorithm that I have, and of course we have to add some stuff to check for whether it's none, etc., is that, for example, here, and I'm going to write it in array notations, but hopefully you get the idea. 3 3 4 4 5, and maybe even just add another 3 for demonstration. But let's say this is current, right? Then we want to see current, these two numbers are the same, so then we remove one of them. And then these two numbers are the same, so we remove one of them. And now at the end of the loop, because this happened once, we just remove one of them. That's basically the idea that I'm trying to go for. Maybe I went by it a little bit fast, but yeah. Found is equal to 4, so let's say found is equal to true, and then if we found, then we remove current dot next, right? So current dot next is equal to current dot next, and that should be good enough to remove that one. Yeah, and then at the very end, current is equal to current dot next, and this assumes that current dot next is not none, but found can only be true if current dot next is not none. So while current dot next is not none and current dot next is not none, and some languages allow you to write this in a query way, and while this is true, we remove current dot next is equal to current dot next. I think maybe that should be good enough. Let's give it a spin. I actually maybe 70% confident at this point, but we'll have to see, right? As you can see, I am wrong on this one. So we did remove the 3's, but I think what happens is that I increment the counter without. So for example, in this case, I removed these 3's, and then but I moved the 2 to the 4. So that's a mistake by me. So I think we should do. Oh no, not this, but else. So if we don't find it, then we could increment the counter. Otherwise, you want to keep doing it again with the new number. So that's basically the idea. I just noticed. And if you wonder why I can debug so quickly, it's just experience and kind of seeing the output, right? So I saw the output, I saw that I was skipping the 3s, and then but the 4s were left in, and I looked at the code, and this was before this else. I was like, oh, this is because I was incrementing. Some of that, or a lot of it, is experience and practicing and kind of making the same mistake multiple times like I have. And when you have, if you made similar mistakes before, then it becomes a little bit easier to to kind of spot your typos or whatever. I want to do a couple more. Oops. But I think that should be good. And of course, just to be clear, the dupes obviously have to be next to each other because it's sorted. I don't know if I said that, but okay. So it looks good on all the at least the weird cases that I tried. So let's give it a submit. Apparently I did it wrong last year, but hopefully I did it right this year. Yay! First try this year. Yeah, beat you, past Larry. 708-day streak. Yeah, and of course this is going to be linear time, even though there's an inner loop before that. You can think about it as each node gets looked at constant number of time. So this is going to be linear time in total, even though there's 2 nested loops, and it may be really easy to be confused by this one. But yeah, you look at it from each node's perspective. You only look at it all one time. So yeah, I'm curious what I did previously before. Oh, did I? Don't know. This code looks funkier. But it seems like I just didn't remove the end of the thing. So yeah. Yeah, this is I guess what I did here was that I reconstructed it piece by piece, and this just leads to more edge cases. You know, the code is actually quite the same size, but don't know. I guess I could add a comment. Skip to. Anyway, I find this one more intuitive than whatever I did in the past, but I could be wrong. Cool. So yeah, linear time, we have constant space because we manipulate the original input, which for a function called delete duplicate, I think it's fair. Usually I'm not a fan of in-place functions, but I think with this one it makes sense, really. So at least as an API, conceptually. So yeah, cool. That's all I have with this one. Stay good, stay healthy, to good mental health. I'll see you tomorrow and take care. Bye-bye.